put some actual data. Pretty simple data set. I haven't really done much with it. I like to kind of throw myself into new data sets whenever I do classes, and then I get all flustered in the middle of the class, and it's a disaster. But we're going to try that again. And so this data set is from SIPRI. In 1966, the Swedish government decided to create a peace institute, and they've been keeping track of arms transfers, imports and exports from many countries since, this data set goes back to 1974. So you can download, you can export that data from their website. You can't just get the whole data set, unfortunately, but you can still get some stuff, and it's pretty cool stuff to have. And I'm kind of just starting to work on this, and this example is just for exports. But the data, we'll see in a minute, there's a URL to my GitHub site, and on the GitHub project for this, there's both imports and exports, and some other stuff, like armed conflicts. I wanted to get to analyze the relationship between armed conflicts and weapons imports and exports, but I didn't really get to that for this. It's kind of out of scope for this particular class, and I couldn't find anything cool, so there was like no clear relationship and more sophisticated methods that need to be done stuff. It's not for this class.
Someone made you an offer you couldn't refuse?
I was threatened with that. No, it's fine. I just didn't get to it. I mean, this data's been around for a while. It's not, and people have published papers on it. It's nothing. I didn't like break into a government computer to get it or something. So let's see here. This, if you open up this CSV file that's on this link, in like LibreOffice, it looks like this. And this is kind of like the situation when you're doing data analysis that you will at times be presented with, unless you're working for a giant corporation that has like a crazy data center or whatever. You have like a CSV file, and the data is formatted in a certain way. A lot of times people will have these files and they just analyze them in Excel or LibreOffice or whatever. But we're going to use Python, and because we're going to do more hardcore things in the future. So we want to just parse this file and do stuff with it. So we're going to have to deal with, there's a blank line here, and then there's the years. And then for each row, there's the country name, and then the exports for each year. And when there's no exports, there's a blank line. So we're going to have to deal with that too. These are just basic mundane things that we have to deal with when we do data analysis. So instead of kind of glossing over it, in this example, we actually parse it. Because you're going to have to parse something eventually if you're doing data analysis. So might as well do it now. There's a library with Python called urllib2. We import that, and we're going to use that to pull something from a URL. There's another library called CSV for reading CSV files. It's nice and easy. And then we have our normal imports. We import NumPy and we import matplotlib. First thing we do is create a file handle. We use urllib to open this URL. It goes to my GitHub. It gets the ARMS exports file that I have listed there. And if you want to play around with this data later, you just change exports to imports, and then there's another CSV file. It's the same thing. We create a CSV reader object using a file handle. We tell it that the limiter is a comma, and the quote character is double quote. And it's important because, I think it's important because this file has quotes in it, because there's commas in the name of the country. So if you don't pass quote character to that, it's going to think that that comma in the name of the country is like a part of the data, and it screws everything up, and it makes you sad for at least like 5 seconds until you fix it. So we are going to read the first row of this data, and we just call reader.next for that. And we're going to just print it. And this is what it looks like. It's a NumPy list, you tell here, and it's got that blank line, and it's got each of the years. And the years are strings, and we don't want the years as strings. We want the years as integers, so we can order them and do fun stuff.
Wait, sorry, hold on.
Yeah.
It's a NumPy list?
This is a Python list. Okay. Because we haven't done NumPy yet, and CSV is a Python library. So we're going to have to process this list. So we're going to create a NumPy array from it, and then we're going to pass a list comprehension. We're going to iterate through the first row, all elements of the first row, and then this is fancy syntax to say we only include elements that have a length of greater than 0. So it ignores this blank line, or this blank space here. And then we cast that to an integer. So what we have here, after we print this out, is a list of years in integer form. It's a NumPy array, actually. It's not a list. It's a NumPy array of years. Much more useful to work in. There's a lot of this stuff in data analysis. You want to get things into a form that makes them easy to work with. And usually, if you're in Python, that form is like a NumPy vector, or a NumPy array or a matrix.
Excuse me. If you skip the blank element,
Yeah. If I skip it, that's another way of doing this.
Kind
Yes.
of offset.
Yes, I can offset this. If I do first row, I can do this. If I did this, then I don't even need the if statement.
No, what I was meaning is that like the years are one part of the array, and each element corresponds to something at the same index,
Yes, same column.
same column array.
Yes.
And if you skip all the blank elements, you're going to have some kind of contraction, and things are not going to be in front of each other.
But I'm just reading this
Oh,
file.
it's just a,
Yeah, so I'm parsing this file. There's probably a million ways to do this.
Okay.
If anybody's interested in more sophisticated ways of working with files, you can look at pandas. I've never really used pandas, and I'm just starting to, but pandas is a pretty good package for reading files and doing all sorts of representation for data. They have an object called a data frame, which is a lot like R's data frame, if anybody's used to using R. So you use pandas. There's PyTables, which is another framework for doing data analysis and for kind of the brute force kind of things you need to do in your data. So yeah. So we have the years, and we read the first column, or the first row. Now we have to read the rest of the file. So what we're going to do is we're going to create a dictionary object, and this is just the way I'm doing this. There are a lot of different ways that one could pre-process data, and it depends on your application. So, just take this as one way of doing it. So I have this variable that exports by country. It's a dictionary. What I want it to be is a dictionary with the key equal to the name of the country, and then I want the value equal to a NumPy array that has the imports, or the exports for that country, and an array. And I want the length of that array to be the same length as the years, so that I can plot them next to each other. So I had that in mind before I even wrote this code. I said, this is what I want. I want this data structure, and I'm going to get that to work. So what we do is we iterate through the reader object, which is the CSV reader object. But we already went through the first row, so this is going to be starting off as the second row. And because the CSV reader object is so awesome, it has parsed everything already and broken things into an array. So I get the first element of the array, and it's equal to a country name. And so I set that equal to a variable, and then I create a NumPy array, an empty NumPy array called exports. And this zeros function is just going to create an array with the shape that I give it. The shape is just a list with one number in it, because there's one dimension, and I want it to be the length of the years array. And then I'm going to fill it in. And I'm going to use a for loop for that. Now, let's take this for loop step by step here. First of all, I'm taking the row, everything that's not the country name 1, and that's what this is. And then that corresponds to export val string, every element in this array. I'm using this enumerate function, which doesn't just give me the index of the elements in that array. So k is the index of each element within each iteration. Now, within this for loop, I'm just going to check to see if the length of the string is greater than 0, because there are those blank spaces in there. I just need to deal with that. So if it's greater than 0, I'm going to set it equal to that element in the exports array. And I'm going to cast it to an integer, because it was a string, and I want it to be an integer. It won't work with numbers. And otherwise I don't do anything, because this array was already initialized to be 0. So if I don't set it, it just stays 0 and it should be 0. So if it's a blank, if it's a blank line, this doesn't get executed, and that element of the array stays 0. And we're good. Finally, I then just push that into the array, or dictionary, I'm sorry. I have this dictionary up at the top here, and I say country name is the key, exports, this NumPy array I've created, and I'm good. And that's all. That's all the parsing for that file. If I wanted to be a little fancier, I would put it in a function. And just call it the function on a file name or something. And then just to verify that it works, I just print out ARMS exports for some country. And then we get the ARMS exports over time. This is the same length, 1974 to 2012, is the years array. And if I want to get the names of all the countries, I call the keys function of the dictionary. It tells me all of the countries that we were working with here. So let's scroll down a little bit. So that's a long list of countries. And we're going to make some plots from it. So the first thing we do, this is just an example plot. We're going to plot the exports for the United States, the Soviet Union, Russia, and Germany. And Russia and the Soviet Union are both in red, and you'll see why in data. So what we have here, when we plot all of this together, is we have the export volume, which is in this kind of abstract number that that Research Institute came up with. That's not quite related to the number of weapons. It's not quite related to the cost of the weapons. It's like the intrinsic value of the weapons. And that's what this number represents. And I don't quite understand, to be honest.
Death value.
Hmm?
Death value.
That's the death value, something like that. So we can see Russia, or I'm sorry, this is Soviet Union. Soviet Union collapses, Russia starts up. So the United States and Russia were neck and neck for a while. Well, Russia was doing pretty well, if you want to call it well. And then weapons exports dropped because the country kind of, went through a change. And then, they're back to, they're the second largest weapons producer in the world. And it's pretty clear, even without this data, you could just Google it or go to Wikipedia and you can see all this information. But it's really nice to have the data here. And then just for, comparison, we have Korea, most likely South Korea. There. And that's their weapons exports. You could plot the top 10 and stuff like that if you wanted. You can play around with this and you can sort a list of things and see what you get out of that. So that's just one plot. And then I don't think there's much left here. All we're really going to do now, we're just going to make a top 10 across time. We're going to average across time. And we're just going to see which countries produce the most weapons on average over the past. France is up there, yeah.
Oh boy.
Right.
Yeah. So yeah, in this code, we make a list of mean exports, and this is just how I chose to do this. There's probably a lot of different ways of doing this. And I have this dictionary that I find useful, and I look at the key value pairs. Country name of the exports is a NumPy array, and then I append to the array. This append is a function it's a list. I append to the list the country name, a tuple that is comprised of the country name and the mean exports across time. Exports is an array over time. Take the mean, we're averaging across time. You can do the standard deviation, you can do whatever you want, whatever your favorite statistic is. And then we sort this list. Now, within NumPy, there's a sort method. It's like np.sort, and you can use that. You're welcome to do whatever you want. This is just the way I do it. I don't know if it's good or bad or anything. And then once I'm done sorting, what I'll do is I'll take the elements out of the sorted array that I want later using a list confirmation. I think I do that here. So, I want the top country names, and so I just get the first element of that tuple, which is country name, and then I want the export value, so I get the second element here. And usually, usually I cast these into a NumPy array, and I didn't in this example, but, you know, I usually would. And then I use a bar graph here. First element of the bar graph is just, I don't really know, to be honest. It's some array that is like the same length as the numbers you're gonna plot, or the things you're gonna plot in the bar graph. I think it could be a list of strings as well. I'll give it a Y label, and then I change the X ticks, and I'll show you what this means in a second. And so I'm gonna make a bar graph out of the mean exports over time for the top 10 weapons producing countries. And this is what it looks like. The X ticks thing, I was saying the country names here, and I was rotating them 45 degrees because it just made it easier to see them at the time. It took up less vertical space. I guess at the top there was one little trick I had to do with NumPy. I had to adjust. Subplots adjust is something to keep in mind, this function here, whenever you are working with plots. You can adjust all the spacing between different plots and things like that. So I just added more space at the bottom so that I could fit the words in better, the country names better. So yeah, this is ARMS exports for the past 20, 30 something years, 40 years. And I think that's it. Is there anything else that I do? No. So yeah, so this is where I left off. And I figured it would be good to give the NumPy tutorial, if you guys interested in that stuff, and you know, accustomed to it, and then just show you a basic data set. And then in the future, what we can do is we can go into this data set or other data sets that people have in mind, and learn, you know, what you do with this kind of data, for example. One of the things that I started working on was I got data on the arms conflicts in the world. From 1946 to like today. It's a pretty good data set, and it's just the whole thing is available. You can download it. So I made an array of the number of conflicts per year, and I made a plot of the total number of arms